Hello class, welcome to week 1 videos for Math 110. I've selected 15 questions that are in chapter 1 that I think you may find useful. So notice that this one is in section 1.1 and this is number 13. And we're talking about set builder notation or set notation. So up top here we have the breakdown of what our notation looks like. We have the set of all elements x such that state what your property is, and then close. So let's go ahead and start with our first one that we're working with. So what you want to do is you want to sit down and look at this and determine, well, what kind of numbers am I looking at? Is there a pattern going on before we start writing our set notation? Remember, if I start going too quick or you don't quite get something, you can always rewind or pause. So on our first one, what we want to notice is we want to look at the different types of numbers that you're working with. These are all even numbers, 2, 4, 6, 8. So these are even numbers that we're working with. And we also notice that they are natural numbers. Okay, they are the counting numbers that we're dealing with that we normally work with. There isn't any negative numbers involved. And they're between the values of 2 and 8. When we say natural numbers, that means we're starting at least the smallest number is 1 and working its way up. So if we're talking about the even natural numbers, then that means that 2 would be the first one. So this is how we're going to write this. We have our notation where we have x such that x is an even natural number. So right now, even natural numbers means 2, 4, 6, 8, 10, 12, all the way on. So we want to say an even natural number less than or equal to 8. So this tells us where it's going to stop. So we have even numbers. They're natural. So we're just talking about working our way up 2, 4, 6, 8, 10, 12, so on. Then we say that it does stop at 8. Let's go ahead and look at the next one. So on the next one, we're in section 1.1. We're still talking, we're still in section 1.1. This time we're looking at the absolute value. So when we're talking about the absolute value of a number, we're talking about how far it is from the number 0. So if you look at our little diagram here, we have the absolute value of -5 is 5. And the reason the absolute value of a -5 is 5 is because all we want to know is how far is it from 0. So we're just talking about a distance from 0. That's why the absolute value of a +5 is also 5, because we're just talking about how far it is from 0. So let's look at our example number 55. So I'm looking at the absolute value of -9. Well, the absolute value of -9 is a +9. Okay, we're talking about how far it is from 0. We have a subtraction between the two absolute values. And then we have the absolute value of -3. Well, the absolute value of a -3 is +3. When we find the subtraction, well, 9 minus 3 gives me 6. So the absolute value of 9 minus the absolute value of, the absolute value of -9 minus the absolute value of -3 is 6. Okay, continuing in section 1.1, this is number 87. The directions say use an inequality symbol to write each statement. Now, inequality symbol, we sometimes only think of the less than, the greater than, less than or equal to, and greater than or equal to. But you want to also include the not equal sign. So this one is saying 5x plus 3 Then we have is not equal to. Is not equal to is an equal sign with a line through it, and it's not equal to 0. So this is actually considered writing this using an inequality symbol. Inequality can be the not equal to sign. Okay. Let's go ahead and look at 1.1 a little further. So we're going to start looking at graphing some solutions of our inequalities. So when we start putting these on number lines, we need to pay attention to what kind of inequality symbol we have. If we have a less than or greater than, we're going to use parentheses at that number. And if we have a less than or equal to or greater than or equal to, we're going to use brackets. And this will probably make a little more sense as we start to work a problem. So let's look at number 101. So we have two things that we're going to do. We're going to take our set notation, which we talked a little bit earlier about set notation, and we want to write it as the interval notation, and we also want to graph. Okay. So what I think is probably a little easier is to graph it first and then come back and do the interval notation. So let's go ahead and graph what we're working with. Okay. So we have x is greater than -1. That's what we're trying to graph. So I'm going to put a 0. -1 is 1 unit to the left. Now here's where we need to pay attention. So notice that we have a greater than symbol. So if you look at our definition we just talked about, our greater than symbol tells us to use parentheses. What that means is at -1, I'm going to use a parentheses. Now I got to figure out which way it's going. Well, greater than symbol means to the right towards the positive numbers. So we're going to have an open parentheses to the right, and this is going to go on forever until you get to infinity. Okay. So interval notation is basically getting rid of the number line. I'm going to keep the parentheses with the -1. I'm going to have a comma saying it's going all the way to infinity. And I'm going to close my parentheses. Now when you're working with infinity, you're going to always use the parentheses. So we have our interval notation, which is parentheses -1 to infinity. And our graph basically looks the same. You have the parentheses at -1, and it's going greater than to the right. So that was a little review of some problems in section 1.1. We're going to also take a look at section 1.2, which gets into working with some fractions. So let's look at our first one in section 1.2. This is asking us to add or subtract as indicated. So let's go ahead and work through our problem. The first thing that I like to do is I notice that there are double signs here, a negative and a negative right next to each other. When you have two negatives right next to each other like this, they convert into a plus. So this is really a fancy way of writing 9/10 plus 4/3. So I think it's easier to get rid of the double signs and just make a 1 plus sign. So remember, a negative and a negative right next to each other equals a positive. A positive and a positive right next to each other is a positive. And then we can also have a negative and a positive, which equals a negative, and a positive and a negative. Okay, so just in case you had forgotten those. Okay, so now let's go ahead and add our two fractions. Now what we're going to do is we want to find common denominators. So I'm going to take my two denominators. My denominator is 10 and 3. Well, 10 breaks down a little bit into 2 times 5. And 3 That breaks down into 3 times 1, so we just have 3. Now, our least common denominator is going to be all the factors we have to their highest power. So if you look at each factor, each of them are only to a power of 1. So that means our LCD is going to have all of those and only to a power of 1. And we'll look at some more later where they have different powers, so you get to see that. So I multiply these together. 2 times 3 is 6, times 5 is 30. So my LCD is going to be 30. Now let's see what that means. So I'm going to have 2 new fractions where I'm going to take the LCD and put it in my denominator. And now I just need to figure out, well, how can I get there from this first fraction? What do I need to multiply my first fraction by to get to a 30? Well, what times 10? Hopefully we can find that 3 times 10 gives me 30. Well, I'm allowed to do that if I do that to the numerator as well. So if you notice, 3 over 3 is just 1. So all we're doing is multiplying this by 1, which doesn't change the value, just changes the way it looks. So 3 times 9 is 27. So that's my new numerator. Repeat the process for 4/3. Again, how am I going to get from 3 to 30? I'm going to multiply by 10. And again, I'm allowed to do that as long as I multiply the top. Okay. Now that we have common denominators, we can go ahead and add these two fractions. And the way that we add fractions is we keep the denominator and we add the numerators. So now we can add these and we get 67 over 30. So since we know that 30 is 2 times 3 times 5, I can check 67. Is it divisible by 2? Will it reduce? It is not even, so no. Will it divide by 3? Go ahead and check to see if this reduces. Well, 3 goes in. No, it's going to be a fraction. Check 5. Well, the problem doesn't end. 67 doesn't end in 5 or 0, so no. So this would be considered our final answer. You do want to check to see if it reduces. MathXL will mark you wrong if you don't reduce your problem completely. So that was adding fractions. Let's go ahead and look at dividing. So the rule with dividing is we're going to change division into multiplication. And we're allowed to do that if we take the reciprocal of the one and back. So when I mean the reciprocal, all I mean is flipping it. So it becomes 5 over 33. The one in front stays the same as negative 22 over 33. So all we're doing is we're changing it to multiplication by flipping the second one. And looks like I have a little typo here. Sorry about that. That should be a 23. Okay. Now we go ahead and check and see, does this reduce at all? Well, 22 and 33 are both divisible by 11. So I'm going to divide out 11, which leaves me with a 2. Divide out 11, which leaves me with a 3. Check the rest of it. 23 and 5 don't reduce. 23 and 2 don't reduce. So I go ahead and multiply it. Now we have a negative times a negative, which is a positive. Remember, we don't have to write the positive sign. So I have 2 times 5, which gives me 10. On bottom, I have 23 times 3, which gives me 69. Again, we want to check to see if it reduces. They don't have anything in common, so nothing reduces. Alright, let's go ahead and look at one more in section 1.2. This gets into adding and subtracting fractions a little more. So let's look at this one. This time there's going to be 3 fractions though. Okay, so the first thing we want to do is check to see any double signs. No double signs right next to each other, so I'm not going to worry about that. I do notice that I'm adding and subtraction, so I do need common denominators. So let's take our denominators. I'm going to move this just to give myself a little room and try to get the problem done on 1. So I take 30, and it's 2 times 15 and 3 times 5. So I have 2 times 3 times 5. In my second one, I have 5 times 9 and 3 times 3. So we have 3 squared times 5. And then 10 is 2 times 5. And I keep working it right below the problem and not giving myself room. So let's move that down again. So I have a 2 times 5. So my LCD is going to be the highest power of each factor. So what I want to look at is I have a 2 here and I have a 2 here. Both of them are a power of 1. So my factor only needs a 2 to the power of 1. I have a 3 to the power of 1 and I have a 3 squared. Well, the highest power is the 3 squared, so that's what I need to keep. And then I have a 5 to the power of 1, 5 to the power of 1, 5 to the power of 1. So I have a 5. Now we go ahead and multiply this together. 3 squared, remember, is 9. So 2 times 9 is 18 times 5 is 90. So my LCD is 90. So I'm going to have 3 fractions this time with the 90. And now we just have to figure out how to get there. Well, let's look at our first fraction. I want to figure out what's it going to take, what do I need to multiply by to get from 30 to 90. 3 times 30 will get me 90, and I'm allowed to do that as long as I do it to the top. So that gives me 21. Notice I already have the minus sign up here, or the negative sign. Now my goal is to get from 45 to 90. 45 is to multiply by 2. So I get a 4 up there, 2 times 2. And then the last one, 10 to 90. I'm going to multiply by 9. Multiply by 9. And we get 27. Now we go ahead and combine our numerators. So we're going to end up with one denominator of 90. And we have negative 21 plus 4 minus 27. So negative 21 plus 4 gives me negative 17. Minus 27 gives me negative 44 over 90. And then I check to see. Let's move down a little bit. So I have negative 44 over 90. I check to see, can I reduce this? Well, they're both divisible by 2 since they're both even. So I reduce them. That gives me 22 over 45. So my final answer is negative 22 over 45. So there's one where you had to reduce at the end to make sure we got to the right answer. Again, you always want to check to see if that's going to happen before you finalize your answer. Alright, well I hope that was helpful, working through a few problems. I have a few more for you in part 2 of the video. I do like to try to keep the videos in 20-minute increments. So please come back for part 2.